In the last video, I gave you an overview of Gensim word embeddings. In this video, we are going to do news classification. We have this CSV file where the news are either fake or real, and we are going to build a classifier that can classify these news into one of these categories. And I took the dataset from Kaggle, so thank you whoever provided this dataset. This is the link. I will provide that in the video description below. I have already downloaded Gensim Word2Vec Google News model, which has been trained on Google News articles. We looked at this in the last video. And we also looked at certain functions of Gensim, such as you want to find similarity between great and good and see almost 72% similarity. You can also get the word vector of these individual words by doing this. So WV is your word vector model. And if you simply treat that as a Python dictionary and give your word as a key, it will give you the vector. Okay. So this will be word vector, let's say great. And we'll do same thing for good, for example. Okay, and when you look at this vector, the shape of that vector is usually 300. So the size of the vector is 300. You can obviously view the vector, which will not make any sense to you. Now let's classify our news category. So I just wanted to show you that there is this functionality available where you can treat these things as just a WV as a simple Python dictionary. So I'm going to load my dataset into pandas data frame as usual. So import pandas as pd dot read CSV. What is the name of my file? Well, here is the name. And if you look at df.shape, you'll find while this is running, I will just print few lines here. So say simple data frame, 2 columns, 9,900 samples. I want to know if there is a class imbalance. So I will quickly do df.label.value counts. If you don't know pandas, by the way, I have a separate pandas tutorial playlist. And you see that there is no class imbalance. They're almost similar size, so I don't have to worry about, treating the minority class and things like that. I will quickly create a numeric column for this label because it is text, right? Our machine learning models, they need numbers. So I will say label number, and this is like df.label.apply. Okay. Or you can just use a map function, either way. And you will say fake is 0 and real is 1. So then if you print df, what it is doing is just creating a numeric representation of your target variable, which is fake or real. I will now convert this into word embedding using Gensim's word embedding method that we saw. Okay. But before that, I would like to do some pre-processing because I want to remove all the stop words. I want to get the lemmatized version of all these words. So I will write this function called preprocess and vectorize because I'm doing two things. I'm preprocessing it and also vectorizing it. Okay. And before I write that function, let me load Spaces large model. And if you have not downloaded this model, when you run this, it will give you an error. And if you find an error, just run this command to download that large model. We saw in the previous videos that the large model contains the word embedding. So you need this. Okay. And through this playlist, we have seen how you can do pre-processing of your text. It is simple. You create NLP object out of your text. Then you will say for token in doc. This will give you each individual token, and you will say if the token is punctuation or token is a stop word, then continue. Otherwise, I will just create filtered tokens list and put the filter tokens into that. Okay, so filter tokens dot append, and I will not put just the token but the lemma. Okay, and let me just show you how this method works. So when I call this method, which is some sample sentence, let's say this one. I don't know if you know, but Andrew Ng's favorite sentence, if you're doing his courses, don't worry if you don't understand. So here it remove don't, then if, and all that, and just lemmatizing it. Okay, if you have things like worrying or something, it will just still get your lemma, which is worry. I also want to do vectorization. So how do you do vectorization? We already saw for one word, you can get the vector by just simply treating WV as your Python dictionary. But what do you do with the sentence? So for sentence, let's say if I have a sentence like this, what I will do is I will get, let's say, worry and understand, right? This is my sentence. I will first get the 300 size vector for this, another vector for this, and then I will average these two. When I average these two, what I get is another vector of size 300, and this is my sentence embedding. Basically, the numeric representation for the sentence. This is the common method that people use in the world of NLP. So let's explore this method called WV. So this WV has this method called get mean vector. So see, I have all this list of tokens here. So if I do get mean vector here and provide list of tokens, right? So if I say worry, understand, it will give me the average of both these two. And if you want to verify it, you can do that by just saying, okay, get individual vectors, of course, right? So vector 1 is this, vector 2 is understand. And once you get these two vectors, you can do np.mean. So import numpy as np.mean v1 v2 v1 v2 x is 0. We have done numpy series as well, so you can look at it, and that's your mean. So I will just print, since the vector is I think 300 size, right? So if you look at the vector size dot shape, it is 300. I will just print first 5, maybe first 5 numbers, or first 3 numbers looks like this, and I will just prove that, see, this is the mean of these two words. So get mean vector for worry and understand should give you the same result. So this is not giving the same result because get mean vector has, if you read the documentation of get mean vector, here it is. It is doing normalization. So pre-normalization by default is true. I'm gonna just make it false so that you get an idea. Okay, so I will say this is false, and now you see these vectors are same. So this is a test that get mean vector is working as per your expectation. If you normalize it, it's good. You know, in machine learning, we usually normalize things. So normalization will even give you better results. So I'm going to normalize it, but I just wanted to show you that get mean vector, the way it works is it takes list of words and it will just give you the mean vector of that. So you don't have to manually do that. So I will just use this function here. Okay. So I will say get mean vector of this. And the reason I want to do this is, as we saw, that this filtered tokens is list of words in a sentence, and I'm interested in a embedding of the entire sentence. And I'm not going to say preprocess false because a preprocessing is good. I don't see why we shouldn't do that. And then when you call preprocess and vectorize, what you get is again a vector of size. How much? 300 exactly. Once we have done this, now comes a part which requires your patience. So I'm going to create a third column in my data frame that will be the vector for this. And how do you get a vector? Well, we call this function. And in pandas, we all know we can do df text dot apply and just use lambda. So lambda text. Okay. When you run this, it's gonna take 10 minutes, 15 minutes, 20 minutes. It's a heavy operation. So go for a walk, and when this is done running, you can come back. I already have this notebook where I have already run this, and see, the vector will look something like this. Okay. And after that, we do our usual process. So we do train test split first of all. So I have 20% test sample and 80% training samples. Okay, using vector.values label number, and then I'll have to reshape these things because hold on, let's see. Okay, I'm creating xtrain and xtaste first, and then I'm creating using np stack. I will create the 2D vector. Why I'm doing this? Well, you can hold on. So if you look at xtrain, for example, right? Look at first two sample. What happens is it's a numpy array, but each individual element is also numpy array. It is not a native two-dimensional numpy array. See, array and then array. But when you do np.stack, what happens is it will kind of flatten it. So now you get native numpy. See, you don't see array and array inside. It's a native 2D numpy array. And we have done this in previous NLP tutorials. That's why I'm not going into details. And I'm hoping that you are following this tutorial in a sequence, because if you're just directly watching this video, some of these things might go above your head. And after that, I'm using gradient boosting classifier. This is again a usual thing. In my machine learning playlist, in my NLP playlist, this is something we have done 1,000 times. So I don't want to waste time typing all this code. And you will see that the performance we get is amazing, right? 98%, see, precision and recall for both the classes. This is 0 means fake class, 1 means the real news class. There's precision recall F1 score. If you don't know about this, again, I have videos. So just in YouTube code basics, precision versus recall, you will get an idea. You need to have all these concepts clear. And then I took some news articles from the same CSV file and did prediction. This was a real news and these two were fake. So when I did prediction, it correctly predicted. See, this is real. 1 means real. 0, 0 means fake. And then I plotted a confusion matrix. Again, confusion matrix we have done 1,000 times in my machine learning playlist, NLP. I'm not going to go in detail. Just to summarize, whatever you see in diagonal are the correct prediction, which means the news, there were 965 news articles in your test set which were true, meaning which were real, they were not fake, and our model predicted them to be real. Same thing here, there were 972 fake articles in our test data set and our model predicted it to be fake. So we got our prediction right on the diagonal, but we got some errors here. So there were 28 which were fakes, because this is truth, which were fake, but our model said it's real. There were 15 which were real, but our model said they are fake. Okay, that's all I have. I have provided a link of this notebook in the video description below. If you like this video, by the way, give it a thumbs up, and you can subscribe to my channel, because I'm seeing majority of the people who are benefiting from these videos are not subscribed. And if you subscribe, it will make me happy. So maybe that's your fees. I'm not asking you for any money. So just say subscribe if you like my videos. If you don't like, don't worry. I still want to say thank you for spending time to watch this video.